All right, today we're going to dive deep. We're talking about the absolute core challenge of large language models, LLMs. This is the big one, the central puzzle that all the smartest people in this field are trying to solve, and we're going to break it all down piece by piece. So let's just start with a really basic question. What does a computer actually need to have a conversation? I mean, a real one, not just spitting back some pre-programmed lines. A genuine, back-and-forth chat. What's really going on under the hood to make that happen?
Now, you might think the answer is going to be super complicated, right? But here's the thing. At a high level, the big picture, it's really not that hard to grasp. We're not going to get bogged down in a bunch of code or anything. We're going to start with something we all understand perfectly.
Okay, so part one, a human conversation. To figure out how a machine talks, we've got to first look at how we do it. Let's start with something we're all experts in. Just a normal, everyday human chat. I mean, think about it. When you're talking with a friend, it just flows, doesn't it? You see or hear a sentence. Then, instantly, your brain just figures out what it means and what you want to say back. And then you just say it. See, figure out, and speak. It seems like a pretty simple three-step process.
Sounds easy enough, right? I mean, that seems like a perfectly good blueprint to hand over to a computer. But, and this is a big but, this is exactly where things start to get tricky. Because hiding inside that simple little model is a massive problem.
Which brings us to part two. But what does it mean? Let's zoom in on that model we just talked about, especially on those two little words, figure out. What do we actually mean by that?
So this is the first big hurdle. When we say a person can figure out the meaning, what are we even talking about? What's happening in your head at that moment? Is it just pulling up a definition? No, of course not. It's context, it's tone, it's shared experience, maybe even emotion. It's a whole bunch of things all at once. It's incredibly vague, if you really try to pin it down.
And, it's the exact same problem with that next step. What do we mean by figure out the response? How do you decide on the perfect words to use or the right tone? How do you know when to make a joke or when to be serious? It's this amazing, creative, logical jump that we just do without even thinking about it.
And that's the absolute heart of it. These are things we humans just get. We have this intuition. But think about this. If I asked you to write down a step-by-step instruction manual for how you understand meaning or how you come up with a reply, could you do it? Probably not. We don't really know how we do what we do. And for a computer, that is a gigantic problem.
Okay, so let's shift gears. Part three, a computer's reality. Because we have to step out of our own heads and into the world of a computer. And it's a totally different place. A computer can't just get it. You see, this is the fundamental difference between our two worlds. We live in a world of fuzzy, abstract stuff, meaning, intent, ideas. But a computer? It lives in a world of pure, cold, hard numbers, computation, and numerical output. That's it. It doesn't understand sadness or sarcasm. It only understands math. So, if you want a computer to do anything at all, you have to build what's called a computational model. What does that mean? It means every single step has to be translated into a mathematical calculation. Every single step. Why? Well, because that's all computers can do. They compute. Math is the only language they speak. So here's how that translation works. All the objects we're dealing with, things like words, sentences, they have to become numbers. All the processes, like our vague idea of figuring things out, they have to become a series of computations, just math problems. And you guessed it, the final output, the response it's going to give, that also has to start out as a bunch of numbers. Everything gets turned into math. And that leads us right into our final part, part four, the translation challenge. Because now that we understand that everything has to be math, we can finally ask the right questions. These are the big, multi-billion-dollar questions that are driving all of the research into LLMs.
So question number one, and this one is a doozy. What kind of computations, what kind of math can actually process the meaning of language? How in the world do you turn a sentence into a set of numbers that somehow captures its essence, its feeling, its entire context? Think about that for a second.
And then building right on top of that, what kind of computations can figure out the response? So once you have those numbers that supposedly represent meaning, what math do you do to them to generate a new set of numbers that represents a totally new, relevant, and coherent sentence?
And finally, once you've calculated that response as just a big list of numbers, what kind of computations can turn it all back into words that we can understand, to speak out accordingly? Answering these 3 questions, well, that's the whole ballgame. That is the grand challenge of turning pure cold mathematics into something that feels, to us, like a real conversation.